In this lesson, we're going to be graphing just simple rational functions. We'll get into more complex rational functions in another lesson. So here we have, if we take a look at this basic one, the graph of a parent function 1 over x is called a hyperbola. It's also called the reciprocal function, so depending on which book you're looking at, it's called different things. It consists of two symmetrical parts called branches, and you'll see that over here in the graph. We've done this when we've looked at domain and range, so this graph should look semi-familiar to you. The domain and range are all non-zero real numbers, so negative infinity to infinity, but we have that break there at 0 because you can't have an x value of 0 because there's an asymptote there. Any function has the same asymptotes, domain and range, as 1 over x. So we're going to, again, just do some basic ones here. It says graph the function f of x equals 1 divided by x using a colored pencil. Now again, for this one, you can just use a different color on your iPad. It doesn't have to be a colored pencil. If you're writing on paper, obviously you would. And then using another colored pencil, graph 6 divided by x. And then we're going to compare the two. So let's take a look here at the graph. Let me erase that. So 1 divided by x. So I'm just going to plug in some points there. So again, I know I have some asymptotes. I have a vertical asymptote right here, right on the y-axis. That's x equals 0. And then you also have a horizontal asymptote right here that's along the x-axis, and that's y equals 0. So some of our points, if I just plug in, if I plug in 1 for my x value, 1 divided by 1 is 1. And then, again, what I'm doing here is I'm just making some points here, some x and y values to get a semi-good graph here. So I plugged in 1, and I got a 1. If I plug in 2, I'm going to get 1/2. If I plug in negative 1, I'll have negative 1. Negative 2 would be negative 1/2. So we kind of get an idea of what this looks like. So let's go ahead and plug in some more of those points. So we plugged in 2, I got 1/2. But if you plug in 1/2, you'll get 2. Remember, we're just taking reciprocals of numbers. Then just kind of drawing the best you can using your iPad. And it is symmetrical around the origin. So this one would be the y equals 1 over x. And then the second one was 6 divided by x, so I'm going to change colors here. So I'm looking at this one. So just choosing some x values. If I choose negative 3, 6 divided by negative 3 is negative 2. If I choose negative 2 for my x value, I'll have negative 3 as my output. If I choose negative 1, I'll have 6. 1 would be 6. 2 would be 3. Running out of room there. And then 3 would be 2. So I'm just going to go ahead and plot what I have there. So negative 3, negative 2, negative 2, negative 3. So here we have the two graphs. The one in red is the parent graph, 1 divided by x, and the one in blue is 6 divided by x. Looking at the, just filling in what we have here, the vertical asymptote for both of them is x equals 0. and the horizontal asymptote is y equals 0. And for these two specific ones, the domain and range are the same. They're negative infinity to 0, union 0 to infinity. And then the range again is the same thing, negative infinity to 0, union 0 to infinity. And then when we take a look at the comparison, some things that you can note about the comparison, they have the same asymptotes, they have the same locator point. Just to kind of give you a heads up when we talk about locator points, we talked about those before. The locator point for hyperbolic is the intersection of the asymptotes. So the locator point for this one would be 0, 0. So if you had a different locator point, you would plot your locator point first, and then you can go ahead and draw those asymptotes. It gives you a little bit better of a definition of where they go. The second one, the one in blue, the 6 divided by x, is vertically stretched because of the a value. That a value is up here, that's the 6. So because the 6 is bigger than 1, this 6 divided by x is going to be stretched out vertically. So that's some things that you would want to write down there in the comparison. Taking a look at number 2, we have 1 divided by x plus 3 minus 2. The locator point in this one is negative 3, negative 2. It's found the same way that we found all the other locator points back before, just to kind of give you the general form of a hyperbolic. It's 1 divided, a divided by x minus h plus k, so that x minus h is in the denominator of the fraction, and then plus k, that's the vertical translation. Now, you can make a little sketch of that. Negative 3, negative 2 is right here. That's your locator point. If you drew a vertical line right there, that's the vertical asymptote, x equals negative 3. And the horizontal asymptote goes right through that locator point also. And that would be y equals negative 2. Make sure that when you write your asymptotes that you write them as equations of lines. It is a line, so you need to write them x equals y equals. If not, they're not going to be correct. And then I'm just going to sketch this in. It doesn't say sketch it, but I'm going to sketch in what it would look like. It would look something like this, just so we can find the domain and the range of this. So the domain for this one is negative infinity to negative 3. That's where that break is vertically. Union negative 3 to infinity. And then the range from the lowest to the highest is negative infinity to negative 2. That's the y value of the locator point. Union negative 2 to infinity. For this next problem, again, this is a hyperbolic. The locator point in this one would be 1, negative 4. Now, again, I'm just going to sketch it out. It doesn't say to sketch it, but I'm going to sketch it so you get an idea of what it looks like. So here's my locator point that I just plotted. If I drew in a vertical line right through that point, that's x equals 1. And the horizontal line would be y equals negative 4. Now, the 2 in the numerator here tells me it's going to be vertically stretched. It will not affect the domain and the range, and since we're technically not asked to draw it, it's not going to really affect anything, but just to give you an idea that it will be stretched out away from the locator point. So that's what the graph would look like. So we already picked out our vertical asymptote, which is x equals 1, and the horizontal is y equals negative 4. And the domain for this one, negative infinity to 1, union 1 to infinity. And then the range, negative infinity to that y value at the asymptote, negative 4, union negative 4 to infinity. For this next graph, 1 divided by x minus 3 plus 2, it does actually say to graph this one. So you have a few options. You can use Desmos if you feel comfortable with Desmos, but keep in mind that you won't be able to use Desmos on a test or quiz, so make sure that you understand how to actually use a graphing calculator if you want to graph these. So you might want to make some notes about what I'm going to tell you, how you put it in the graphing calculator. So the first thing is the vertical asymptote. I would probably go ahead and start by figuring out the locator point in this one, because the locator point will help you determine those asymptotes. So the locator point for this one would be 3, 2. So the vertical asymptote is x equals 3. Horizontal is y equals 2. Again, keep in mind that I'm getting those because these are the values of those locator points, 3, 2. So the x is 3, y is 2. There are your two asymptotes. So I'm going to plot those 2 points, or those two asymptotes. So 3, 2. And then draw in my asymptotes. Now when you graph it on your calculator, the calculator will not show you the asymptotes. You just you can see and visualize where they are, but they won't draw them in for you. So this is your y equals 2 and x equals 3. Now, what I did was, to kind of speed this up a little bit, I did put it into Desmos, and I'm going to import that picture over top of mine that's here on the right. Now, again, just a few things about putting it in the graphing calculator. You don't have to worry about these when you do Desmos, but in a graphing calculator you do. So in number 4, you would go into y equals, and you would type in 1, and then the divided by sign. And you're going to have to open up a parenthesis at this point, x minus 3. So you're putting parentheses just around the denominator, plus 2. If you put parentheses anywhere else, you're probably not going to get the correct graph. So make sure that you make a note to only put parentheses around the denominator. Some students think that you put it in front of the 1 and then after it. That's not where it goes. It goes around the x minus 3 and only around the x minus 3. So I'm going to go ahead and add in that picture. Let's see what we have here. So again, you want to make sure that you add in. You don't have to necessarily. I've made it so that it has a table. So here I have, I put the table over here on the left. You can also do that as well. In Desmos, there's a little picture that looks like a little table. And then I was able to just add in different x values, and I added enough so that I could get a relatively good idea of what it would look like. And you can see here, even though it's not drawn in Desmos, you can see those asymptotes, that x equals 3 and the y equals 2. So for this next one, we have 4 divided by x minus 2. The locator point for this one, again, always the first thing I do when I graph these, would be 0, negative 2, because in the denominator with the x, there is no number, so it would be 0, x minus 0, and then minus 2 is your k value. So your asymptote, your vertical one, would be x equals 0, and the horizontal y equals negative 2. Oh, we never did the domain and range for the one up here. So the domain for this one would be negative infinity to 3. It's not a negative 3, that's just 3. Union 3 to infinity. And the range, negative infinity to 2, union 2 to infinity. Sorry about that. So let's hop on down to this one. And you can go ahead and try this, putting this in your graphing calculator, figuring out the domain and range. I'm going to plug it into Desmos so I can take a picture of it and put it over top. And then see if you can figure out how to put the table in Desmos as well. If not, you can ask one of your, either somebody around that knows, you can ask myself, you can ask Mrs. Lutz. So whoever you need to ask to figure out the domain or the table in Desmos, please make sure you do that. Now keep in mind that for your test and quiz there's a non-calculator portion, so there will be a time where you're going to have to be able to plug in some of these values. And again, I just use a calculator, and you're just estimating these. We're not necessarily looking for exact, but we want something more than just 1 or 2 points. So here I have mine on Desmos, so this is what it would look like. And the domain of this one would be negative infinity to 0, union 0 to infinity, and the range negative infinity to negative 2, that's that horizontal asymptote, union negative 2 to infinity. Now this next section we're going to deal with rational functions that are not in the same form that we've been looking at before. So all the forms that we looked at before were a divided by x minus h plus k. So that's when we found the locator point h comma k. So now we have rational functions that are still considered hyperbolas but not in the exact form that we've been working on. So for this one we have ax plus b, so we have a binomial in the numerator and a binomial in the denominator. And then they have a vertical asymptote of x equals negative d over c. Again, I'll show you how to do that on the next page. And then they have a horizontal asymptote of a divided by c, so just your coefficient of x's. So let's go ahead and practice some on the next page. So to check out for any vertical asymptote, you take your denominator and we're going to set it equal to 0. So my denominator in this case is x minus 3 equals 0. And then we'll solve for x, and that gives you your vertical asymptote. That tells you where your domain is restricted, if you remember back in Unit 3. So here we have an x value of 3 as your vertical asymptote. For your horizontal one, you're going to take your coefficients of x's. So in this case it's 2 and 1. So you'll just divide those out. So you'll have y equals 2 divided by 1, or just simply y equals 2 as your horizontal asymptote. For your x-intercept, the same way that we found x-intercepts pretty much the entire time is you set y equal to 0 to find an x-intercept. So 0 equals 2x plus 1 divided by x minus 3. When you cross multiply here, you're going to multiply 0 times x minus 3, which is just going to simply give you 0. And then when we cross multiply over here, remember there's a 1 that's underneath of the 0, so we're going to multiply 1 times 2x plus 1. So to solve for x, we would subtract 1 and divide by 2. So your x-intercept in this one would be negative 1/2, comma 0. Now, just on a side note, the only time any fraction will ever equal 0 is when the numerator is 0. So if the numerator of any fraction is 0, the entire fraction is 0. So it's pretty much safe to say that if you have a fraction, you would set the numerator equal to 0 to give you your x-intercept. If you can't remember that, just go ahead and cross multiply. The y-intercept will make x equal to 0. So you'll have 2 times 0 plus 1 and 0 minus 3. So in the numerator, that'll give us a 1, and in the denominator, negative 3. So your y-intercept is 0, comma negative 1/3. And then again, I like to graph them before I find the domain and range. So again, keep in mind that when you do find, when we actually do go ahead and plug this in the calculator, you want to make sure that you put parentheses around your numerator and your denominator. So in the calculator, it would look like this: y equals parenthesis 2x plus 1. And then you'll close that set of parentheses and then divide it by, and then another set of parentheses for the denominator, x minus 3. Now I always like to kind of take a look at all the different things I have, and then I put it in a calculator. So x equals 3 is my vertical asymptote. My horizontal asymptote is y equals 2. This gives me an idea whether or not I typed it in the calculator correct. If they don't match up, then I know I did something not correct. So my x-intercept was negative 1/2. And then my y-intercept was negative 1/3. Just do your best to estimate it the best you can. So at this point, I'm going to go ahead and type it in the graphing calculator to get more accuracy with my points. So I'm going to go ahead and add in that picture that we have of what it would look like. Make it a little smaller. So I'm going to have to cover some of that stuff up. So here we have a look at what the graph looks like. So for the domain for this one, you would have negative infinity to that vertical asymptote, which is 3. So negative infinity to 3, union 3 to infinity. And then we have a horizontal asymptote that this hyperbola is not going to cross over, so that affects your range. Negative infinity to 2, union 2 to infinity. In this last problem that we're going to do, we have y equals 3x minus 6 divided by 2x, or x plus 2. The vertical asymptote again is found by setting your denominator equal to 0. So x plus 2 equals 0 is your denominator. We'll solve for x. So your vertical asymptote, x equals negative 2. The horizontal asymptote is found by taking the coefficients of your x. So in the numerator it's 3, in the denominator it's 1, and dividing them. So you get y equals 3 divided by 1, which is just 3. Your x-intercept, you make y 0. So we'll have 0 equals 3x minus 6 divided by x plus 2. We'll cross multiply, and that leaves us just 0 equals 3x plus or minus 6. To solve that equation for x, I would add 6 and divide by 3. So that gives me an x-intercept of 2, 0. My y-intercept is found by setting x equal to 0. So we'd have 3 times 0 minus 6 divided by 0 plus 2, which would be negative 6 divided by 2, or simply negative 3. And then I'm going to plot that information before I plug it in the graphing calculator. So x equals negative 2 is my vertical asymptote. So we'll jot that down. X equals negative 2. Then y equals, for your horizontal, y equals 3. And then my x-intercept was 2. My y-intercept was negative 3. And now I get an idea of whether or not, when I type this in the graphing calculator, if I've done something incorrectly. So I'm going to go ahead and put this into Desmos. You can try it in your graphing calculator or Desmos, see if you get the same thing. So off to the right, you'll see the graph that I put into Desmos with some of the points that I chose in my table. The domain for this one would be negative infinity, negative 2. Union negative 2 to infinity. And the range would be negative infinity to 3, which is where your horizontal asymptote is, union 3 to infinity.